equilibrium. Keep the heading, okay? Thermodynamics for equilibrium. How we will use thermodynamics for equilibrium? Thermodynamics for equilibrium. What is the formula for thermodynamics? Delta G formula. Do you remember delta G formula? Delta G is equal to delta G naught plus 2.303 RT log K or log Q, for example. Log Q in the sense reaction at somewhere. Here, what is delta G? Delta G is Gibbs energy change or change in Gibbs energy. We can use Gibbs energy change, Gibbs energy change or change in Gibbs energy. This is standard Gibbs energy change. Standard Gibbs energy change. When we say it is a standard means condition. 1 bar pressure, 1 molar concentration, certain temperature like room temperature, certain temperature, not only room temperature, whatever the experimental condition temperature. If they maintain certain temperature, room temperature or certain temperature, we usually say that particular, because all reactions, according to that reaction, that particular temperature. Okay. Suppose instead of 2.303 log, we can say ln. 2.303 log is nothing but ln. So same formula, delta G is equal to delta G naught plus 2. ln RT ln Q. Can I write like this? Delta G is equal to delta G naught plus RT ln of Q. What is this? ln is nothing but 2.303 log. ln is nothing but 2.303 log. Is it clear? Got it? Right. Now, I will tell you some conditions. These are the conditions which we, seen in case of second law of thermodynamics. Once if you remembered or not, please check it out. Delta G is useful to find the spontaneity of a reaction. Spontaneity of a reaction. Which one? Delta G, not delta G naught. Delta G naught is standard conditions. Delta G will be helpful for us. This is useful to find the whether reaction is possible or not. Spontaneity means possible. Reaction possible or not, we can find based upon delta G. Correct? If delta G is equal to 0, then the reaction is at equilibrium. If delta G is negative, tell me, negative means delta G less than 0. Negative less than 0. Before 0, what are the numbers? -1, -2, -3. Delta G negative means it is a spontaneous reaction. Spontaneous. If delta G is positive, then delta G greater than 0. Non-spontaneous reaction. this is what which we learned in second law of thermodynamics. Repeat the conditions. Delta Z is 0 for equilibrium, delta Z negative for spontaneous, delta G positive for non-spontaneous. See, here we don't want all this. We want only delta Z 0 because we are talking about equilibrium. So what you have to substitute? Delta Z 0. Okay. Now, let us see. I'll take a whiteboard. Okay. Delta G is equal to delta G naught plus 2.303 RT log Q. Okay. But what is the condition? Delta G is 0 at equilibrium. When reaction is at equilibrium, Q becomes Kc, QC becomes Kc. When reaction is at equilibrium, Kc means equilibrium constant. So, 0 is equal to delta G naught plus 2.303 RT log Kc. We already completed one more time. Delta Z naught is equal to minus 2.303 RT log Kc is the formula. Circle this formula, everybody. What is this? This. Clear? Got it? Okay, fine. We all came to know the formula, right? Hey, go. Done. Now, let us see. Delta G naught is equal to, what is the formula you got? Minus 2.303. Suppose a reaction is there. Write one question. Write one question. Write one question. A gives rise to B. A gives rise to B. K is equal to 10 power 10 at 27 degrees Celsius. Calculate delta G naught. Your time starts now. Everybody, come on. Find delta G naught and tell me. A gives rise to B. Every data is there. Every data is there. How we should solve this question? Every data is there. Delta G is equal to minus 2. Z naught is equal to, important. We are finding Z naught, not G. Delta G naught is equal to minus 2.303. R value, which R value we have to substitute? Again, summary. One more time. There are two R values you have to use here. One is 8.314. One is 2. Only these two. Why? Because suppose gaseous state chapter, I told you 0.0821. See, it is important to learn every chapter, because if you don't learn gaseous state chapter, then you don't learn pressure conversions, volume conversions, temperature. Huh? Okay. So, right, you already learned, so no problem. 8.314. Why we have to take these two R values? Because its unit is joule per mole Kelvin. Here joules, energy. Joule is energy unit. 2 calories per mole Kelvin. So calories is the energy unit. If you see other R value like 0.0821 ATM liter, those are with respect to the pressure. Okay. So you should use these two R values. Got it? Now substitute the R value 8.31. Let's say R until sometime. What is the temperature? 27 means add 273. Why? Degree Celsius is there. Convert into Kelvin. 300 Kelvin. So into 300 log Kc. What is the K they have given? 10 power 10. Right, everybody? Log A power B formula is B log A. What is the formula of log A power B? B log A. Got it? B log A. Now, delta G naught is equal to minus 2.303 R into 300. The 10 comes before log 10. Log 10 is 1. Then delta G naught is equal to minus 2.303 R value. Let me take in joules. What is the trick to find? See R, see how easy it will be. If you substitute 8.314, then your method of doing, others' method of doing will become same. It consumes same time. So you should use the techniques while solving. What is that? 25 by 3. Then 1s are 100s are. 100 into 10,000. So 2303 into 25. Everybody clear? Units will be joule per mole Kelvin. What do you say? Joules, joule per mole, joule per mole. Understand? Got the clarity? Because joule per mole Kelvin, our temperature unit and this temperature unit will be cancelled. We will be having joule per mole. What do you say? Now moving. This numerical also we have done already. In thermodynamics chapter, delta G formula and numerical. Fine, it is over. Now, sorry. We have seen one formula. What is the formula? Delta G naught is equal to delta H naught minus T delta S naught. Do you remember this formula? Repeat this formula, everybody. Delta G naught is equal to delta H naught minus T delta S naught. Fine. Listen carefully, pay attention. Delta G naught is nothing but, now only we came to know, minus 2.303 RT log Kc, I should say. Why Kc I am telling? Because we considered equilibrium condition. Delta G became 0. So Q plus Kc we got. Listening. Then, which is equal to delta H naught minus T delta S naught. So what I'm going to do is divide, Mridula, divide both the sides with what? Divide both the sides with minus 2.303 RT. Both sides. Means I'm bringing this towards this side. I can say, or divide both the sides with 2.303 RT. Okay, divide. Let's divide. Minus 2.303 RT log Kc. Come on, divide everybody. Divide. Minus 2.303 RT delta H naught by minus 2.303 RT minus T delta S naught by minus 2.303 RT. Until here, everybody clear? Just we have divided with the 2.3. Why we have divided? Actually, I can say direct step only, but one more additional step so that you will easily grasp it. Now, this term will be cancelled. Still, what will be cancelled? Temperature will be cancelled. Correct? Now write the final expression. Log Kc is equal to see towards the screen. Can you see my pen cursor on the screen when I'm doing like this? Like this? Okay. See here. Minus of minus. What it will be? Plus. So, shall I write plus first? Because we always write A minus B, not minus B plus A. What we will write? Minus B plus A is there, means we will feel like to write A minus B. That is easy for us. So, instead of writing minus term first, we will write plus term first. Okay. So, delta S naught by 2.303 R minus delta H naught by 2.303 RT. Come on. Take out this formula. Clear, everybody? Clear? Log Kc is equal to, repeat, you all should remember this formula. Log Kc is equal to delta S naught by 2.303 R minus delta H naught by 2.303 RT. Okay, fine. This formula is okay. Fine, this formula. How to find Kc? Kc also we know. Normally, not in this formula. I'm not talking about in this formula. Usually, we know how to find Kc also. How to find Kc? For example, one reaction is there. How to find Kc? Products concentration by reactant concentration, whose stoichiometric, say, you should say, products concentration divided by reactants concentration, whose stoichiometric coefficients are raised to the power. So, C to the power of C, D to the power of D, A to the power of A, B to the power of B. Means these are raising to their powers. Got it? So, Kc, one important point I want to tell you. Numerator also concentration, denominator also concentration. So, Kc is unitless. Unitless. Suppose, with respect to Kp, how to write? Pressure of C to the power of C, pressure of D to the power of D, pressure of A to the power of A, pressure of B to the power of B. So, numerator also pressure, denominator also pressure. Say Kp is also unitless. So, Kc and Kp are unitless. Okay? But they did not give this option in your exam. Unitless word is there. First priority, mark unitless. For example, unitless option not there. They have given you some units. Then how you should solve? Then Kc is equal to concentration to the power delta Ng. Okay? Concentration means mole per liter. Mole per liter to the power of delta Ng. How to find delta Ng? Value gaseous products minus gaseous reactants. Only gaseous. See, each and every point clearly I'm discussing. Now it is your responsibility to prove yourself. How many times you will do a practice? Come on, come on. Clear? Case is clear? Now tell me Kp. ATM to the power of pressure to the power of delta Ng, na? Their concentration, here pressure. Ma'am, if both options are given, then what I should select? If some units also given, some some units also given, and some what to say, pressure also given. Strong body, Komali, yours. So what we should do? First priority is we have to mark unitless. Okay, unitless. If they did not give unitless, then only you should take pressure and or concentration units. Got it? So first priority is for unitless. Done. Now, leave this one. Before what we are discussing, tell me the main formula which we are discussing. Which formula we are discussing? Log K or Kc usually. Log K or simply I can write K. What is that? Delta S naught by 2.303 R minus delta H naught by 2.303 RT. Am I right? Am I right? Now, here two conditions I'm going to discuss. Let's see those two conditions. Delta S naught greater than 0. Delta S naught less than 0. What is the meaning of delta S naught greater than 0? Change in entropy is positive. Positive. Delta S naught value is positive. Here delta S naught value is negative. Less than 0. Everybody clear? Most important. Now, this value is positive. First case. Second case, this value is negative. Two cases. Entropy, delta S change in entropy can be positive, can be negative. Two cases. Again, in this two cases, that reaction can be a exothermic reaction or that reaction can be a endothermic reaction. So, this delta H I'm talking about, that can be greater than 0 or that can be less than 0. Everybody listen. Delta H naught is greater than 0. What is the meaning? Delta H naught is positive. Here, delta H naught is less than 0, which means that delta H naught will be negative. So, delta H naught is positive means which reaction? This is positive means endothermic reaction. Endothermic reaction. Okay. Now, see here, delta H naught will be negative. Delta H naught will be negative means which type of reaction it is? Exothermic reaction. Exothermic means we are giving the heat. We are giving the, it is releasing the heat. Exothermic means it is releasing the heat. Endo means we are giving the heat. Okay, fine. Ma'am, why, ma'am? Now, what you are going to tell us? Listen carefully. Listen carefully. Log K is equal to delta S. Same formula I'm going to write. Hey, why you come only eraser? If you come only eraser, I should erase. Okay, see here. Log K is equal to delta S naught by 2.303 R minus delta H naught by 2.303 RT. What I want to tell, listen carefully. This is positive. Delta S positive means this whole value will be positive. Okay, na? This whole value. This is positive into negative. This delta H is positive. No. Positive into negative, negative. Okay. So, this value is negative only. This value is positive only. No problem. This value is negative only, this value is positive only, no problem. So, let's see the graph. Let's see the graph. Between what and what? Log k and 1 by t. This is y-axis straight line equation. Everyone must be familiar. Okay. Y is equal to mx plus c. Repeat everybody. Y is equal to ma'am. Y is equal to mx plus c ma'am. Y is equal to mx plus c ma'am. Y is equal to mx plus c. Huh? Then what is the y? Y means what we are going to take on y-axis. What is the x? What we are going to take on x-axis. And what is a C? C is our intercept. Intercept in the sense, intercept where that line is touching y-axis. Line touching y-axis. If you want, you don't, those who don't know, you write intercept means line which is touching y-axis. M means slope. Already we discussed. One more time. Y is equal to mx plus c. So here this 1 by t is there. No, this 1 by t. Remember, 1 is not there. You are writing. Already 1 is there. Nothing is there. 1 is there. 1 by t. Now, this is my y is equal to, this is m. 1 by t is my x. So that term will be my mx plus c. So what is the intercept? Intercept is some value. That value is delta S naught minus 2.303 R. Everybody accepting? Accepting. This is my intercept. What is my slope? Negative na, positive na? Negative na, positive? Negative. So the graph will come down like this. So the graph will come down like this. Why graph comes down like this? Because slope is negative. Slope is equal to negative in the sense how much is the slope? Minus delta H naught by 2.303 R is the slope of the reaction. Got it? Got it? Crystal clear? Right. Very good. Now, shall we see in the first case? Case number 2 again. This is case number 1 again in this part A, part B. Shall we see this graph now? Shall we see this graph now? Okay. These are which reactions? Can you tell me? Class is recording, no? Huh? Their top it is coming recording? Okay, if any time if I forget means please inform me. Otherwise the evening class damal. Delta H naught will be less than 0, correct? So now tell me which term? Log K is equal to, say the formula. I'll use the same color pen. So log K is equal to delta S naught by 2.303 R minus delta H naught by 2.303 R into 1 by t. Correct? So now this is negative. This is negative now. So negative into negative, positive. Anyhow, delta S positive only. But negative into negative, this term also becomes positive. In this case, slope negative na, positive na? Positive. Positive. Why positive? Because this is an exothermic reaction. That is one of the condition. Delta H negative. That negative, if you bring here, that will become positive. Now see the graph, how it will be. Now equate that with y is equal to mx plus c. Y is equal to mx plus c. Draw the graph, everybody. On y-axis, I'm going to take log k. And x-axis, I'm going to take 1 by t. What is the intercept? Come on, say what is the intercept? Huh? Intercept, intercept, intercept. Say loudly. Shout the answer. Delta S naught by 2.303 R. Super. Positive slope na, negative slope na? Listening. See, very easy. Delta H place, I am substituting condition negative because two conditions. One is positive, one is negative. Positive, already over. Negative. So here negative into negative. It becomes minus 5 into minus 5. Minus 25 na? Minus 10 na? Minus 5 into minus 5, minus 25. So, I plus 25. Oh my God. So, here negative into negative, it will become positive. So, the graph will be how? Tell me. Increase. Shaking. Now, correct? Clear, everybody? Clear? Right? So the graph will be like this. You will by heart it. How can you by heart? You should apply it and you have to draw the graph. Now, see the next condition. What is the next condition? Delta S is less than 0, means negative. Again, two conditions. What are those two conditions? Delta H can be greater than 0. Delta H naught. Delta H naught can be less than 0. Greater than 0 means positive. Less than 0 means negative. Which is endothermic reaction? Endothermic reaction. Which reaction? Endothermic. Endothermic. So we are taking two conditions. One time we are considering they may ask you, which of the following is the correct graph for exothermic reaction? Which of the following is the correct graph for endothermic reaction? You should be able to identify. Okay. I'll give you all set of practice questions, everything I'll give you. Okay. Everything will be clear during class itself. Listen carefully. Practice. Okay. Today evening you practice it. That will be awesome if you do on the same day. Endothermic reaction. What is this? This will be exothermic reaction. Now, let's draw the graph. Come on, everybody, take the formula. What is the formula we got here? Tell me. Log K is equal to, ma'am, delta S naught by 2.303 R. Same formula. But you should learn the way to draw the graph. Okay, 1 by T. This is the formula. Okay, na? So I'm not having a space, so I don't draw the same formula. Write this side. You write that side also same formula. Same formula. Here also you write same formula. What happened? Sangeeta, unmute your phone.
Ma'am, del is negative, right, in this case.
Correct. We will see now. Still, I did not substitute. Got it? Still, I did not. I wrote the formula. Now, let us see. What is the condition? Now, we will apply. Same formula, you write both the sides. Now, let us see. What is this? Here, this will be negative. Okay. So, this is negative. And minus of, this is negative into positive. So, this is also negative. This is one tabular column which we have done in thermodynamics chapter. Do you remember? But there we consider temperature also because it is a thermodynamic. Here also we can see that too. Okay, negative into negative. So finally, what I want to tell you now, draw the graph, everybody. Draw the graph. Y is equal to mx plus c. Very interesting it will be. Very interesting. What we are going to take on y-axis? What we are going to take on y-axis? Sangeeta, unmute your phone, Sangeeta. Sangeeta, fast. Hi, Sangeeta.
Yes, hi, ma'am.
What we should take on y-axis?
Log K, ma'am.
Log K. X-axis?
1 by T.
1 by T. What is the intercept?
Intercept is negative, ma'am. It is minus del S naught.
Very good. Intercept is negative. So I should, this is 0. Okay. The above 0 is positive intercept. Okay. Now that is negative intercept. So little graph I will draw, little top. Little top I will draw. So that little top I'm drawing, little top. Okay. This is same as it is. What I have taken here, something is erased na here. Okay. Here what I have taken same log k only. Okay. This is as usual 1 by t axis only. But somewhere here is some intercept before case. Before case. Positive value. 0 above what numbers will be there? +1, +2, +3. Down of 0, what numbers will be there? -1, -2. So intercept is some negative value. How much that negative value intercept here? Intercept is how much? Delta
Minus
S
del
naught.
S
2.303.
2.303 R.
So this will be negative value. Why negative delta S? Negative condition we have taken. Negative intercept. Okay. Now, here they were telling that slope. Slope is
Negative, ma'am.
negative. No, negative means
Decreasing.
graph will be comes down only. You just, here I'm drawing. You can't see my screen. So here I'm drawing. Here, intercept. This is intercept. What is the intercept value? Minus delta S naught by 2.303 R. Then it is, the slope will be like this. Graph comes down. Easy, everybody? Any difficulty? No difficulty. Now see this case. Sangeeta,
Yes, ma'am.
tell me, delta S will be same formula you have written. No, everybody, this side also write same formula. Same formula this side also.
Negative, ma'am.
Delta S will be negative. So this term will be negative. Next term will be
Del H is negative, ma'am. So that term will be positive.
positive. Super. Now let us see the graph. Okay. Let us see the graph. This is, I'll change the color a bit so that you will be able to catch. This is log K. Now, what she was telling is, ma'am, delta S is less than 0, which means always negative. Negative means intercept will come less than the axis, ma'am. So here, but ma'am, here delta H is coming positive because delta H negative, ma'am. Negative into negative, this term becomes positive, ma'am. So slope is positive. Positive means how, Sangeeta, how it goes?
Graph goes up, ma'am.
Very good. Graph goes up from this point. Straight, okay? You should not draw any curves. Straight you draw. Okay, like this. Some straight line like this. Okay, now everybody? Clear? So these are the 4 graphs. The first 2 are most important. Next 2 also. Once have a look. Depending upon the type of questions you solve, it will be useful for you. Sangeeta, come on, good girl. High five. Super, super, very good. So with this, we have successfully completed Gibbs free energy related concepts. All concepts, any question, everything I covered. All things I have covered. Okay. Shall I move now? Lead Chatelier's principal is waiting for you all. Take screenshot if still anyone is copying. Now, Let me start Lee-Chatellier's principle. Lee-Chatellier's principle. Put the heading. Factors affecting composition of equilibrium mixture. Factors affecting composition of equilibrium mixture. Factors affecting composition. Actually, what is the meaning of, listen carefully. You can't by heart and solve the questions from this. Every concept you need to understand, because increase, decrease, increase pressure, decrease pressure, increase temperature, decrease temperature, increase concentration of reactants, products, like this, various models will be there. So what I'm teaching, it should fix in your mind, like with a Fevikwik. If you stick anything, how it will stick, like that my words should stick in your mind. Listen carefully. Factors affecting composition of equilibrium mixture. What is the meaning of composition? Nothing but the moles. What is the moles or moles of the mixture? What is the moles of the mixture? Reactants. I'm talking about composition. Okay. Reactants and products moles. Reactants and product moles. How these moles will change? If you change these moles, how the equilibrium will change? Okay. One boy one day asked, ma'am, this Kc, Kp, why they don't depend on concentration pressure? We are doing so many numericals, no? But all that we are changing, something we are changing. But again, we are telling that Kc, Kp don't depend. Then what we are changing, like that one question. You will understand the meaning of this under Lee-Chatellier's principle. Okay. Before going to start this, what this Lee-Chatelier, what principle he gave? He gave that if suppose someone came, your mother came to slap you, instead of one cake piece, you ate your brother cake piece also silently. Only two are there. He told, hey, I'm keeping here. I'll do bath and come. You wait. You don't eat. He told and went. Only two pieces are there. It is already night 10:30. Your father bought for both of you. You had that piece also. Then what your mom will do? Hey, one slap I will give you. She do like this. No, then what you will do? You will keep your face front, or you go a little back. Mummy, come on, mummy. I'm Gandhiji's sister. If you beat this side, I'll show this side. You say no, no. Nicely, you will go back, run back. Means opposite reaction you are showing. Opposite reaction you are showing. Same way, Lee-Chatellier's principle also. What this Lee-Chatellier's principle? If we do, listen carefully. If we do any change, equilibrium will shift in such a direction, in opposite direction, to reduce the change. For example, if you increase the pressure, equilibrium tries to decrease the pressure. If you increase the concentration, equilibrium tries to decrease the concentration. If you increase the temperature, equilibrium tries to decrease the temperature. If you increase the number of moles, equilibrium tries to decrease the number of moles. So always equilibrium tries to shift in such a direction to decrease the effect. Write the definition, everybody. If any change like equilibrium concentration, equilibrium pressure is done at equilibrium, then equilibrium will shift in the direction where it can minimize. Come on, everybody. Write the definition. I'll explain you. What is that? If you do any change, how the equilibrium will shift? Equilibrium shift in such a way to minimize the effect. Simply to say opposite direction. Opposite direction.